Hello, and welcome to part 4 of my GSA Introduction Tutorial video series for university students. Today we're going to look at how to get some results from your model and also how to annotate it to get more precise values than just blocks like so. So for starters, from last time, we applied a point load at node 4 and a UDL across beam 2. However, it's not entirely obvious exactly how big these forces are. So you want to go over to this far side over here, and you want to go down, select for annotation. So select for annotation is essentially, you go onto your model view, and you highlight a certain aspect, and it will tell you what that value is. This is for everything here. So all loads, all displacements, reactions, axial forces, shear forces, bending moments, and so on and so forth. So now that we've highlighted this, it will show us that this point load has a magnitude of 3 kilonewtons. If we highlight the UDL, it will tell us that this UDL has a value of -1 in the Z direction. Now, it is incredibly important. This is something a lot of people make a mistake on. They will simply go like this and think just because it's in the middle, it'll take the entire thing. But no, you need the entire force, the entire beam, the entire node. If you want something annotated, you need to highlight the entire thing, right? So just keep that in mind. So now that we've annotated it, we know we're applying this load here and this load here. If you're happy with how your model looks and you're ready to test it, simply click Analyze. And yep, you should get no errors or warnings found. If you do have an error or warning, that means normally it's because you've missed a degree of freedom and you've created a mechanism. So if you're having that trouble, make sure you've applied your restraints correctly. Make sure all your elements connect correctly to your loads. All values are applied in the correct axis. So yep, you should get this now. And now if we go back to our diagram, if you want to go back to, so right now I'm on annotation mode, so I can't rotate the camera. If you just click on rotate or click the R button, you can go back to rotating your camera. So now that we've got this, we can look at the displacements. So if we turn the forces off and just look at how it's reacted to it, so these green arrows are the displacement values. If you want to see this visualized properly, you go over here, deformed image, and it will show you the deformed image of what it looks like. So this is what it would look like if you applied these forces. Now, very important, some people get scared when they see this. This is at deformation, magnification 200 times. This is being deformed 200 times more than it actually is. These two buttons, this times by 2 and double the size and half 2, these will change this value. So if I click this, we're now at 400 times magnification and it's bending even more. However, if I click this a bunch of times, we're now at 1.5 times magnification, which means it's the actual deflection is being magnified 1.5 times, and it basically looks like it's not bending at all, because in reality, we're only bending by a few millimeters. So yeah, that's something to keep in mind if that ever scares you. But for now, we're going to leave it at 200. We go over here, back to the annotation button. Highlight. So if I just highlight this beam here, it will give me the deflection values. These are in millimeters, by the way. You can tell because the magnification shows it barely budges. So whereas this is a 5-meter gap, this is 2.5 millimeters. So you're basically not going to be able to see it. But yeah, if I annotate only this beam, it's only going to show me these values. If I annotate the middle of this beam, it's not going to show me anything. You need to get the entire beam in, and then it will annotate that. So we get the entire structure in. We can now see, go back onto rotate. This is exactly how much deflection this structure is undergoing right now. And that's through the displacement diagram. So then you can add the reaction diagram, which is, so yeah, that'll give you a reaction force here. So again, we annotate this, gets rid of them, but shows us exactly how much of a force is being applied to our points. Axial forces, how much axial force is going through all the members. Shear force, how much shear force is going through all the members. Bending moment, how much bending moment is going through all the members. And yeah, that should, generally speaking, for your university coursework and that, you'll only need the maximum values at the edges. So if you need like values in the middle, you shouldn't, but there are methods. That's when you would need to come over here for stuff like that. But yeah, so yeah, with these 4 tutorials, you should now be able to make basic structures using only this portion of GSA, and hopefully it's made it a bit more simple for you. So yeah, you're welcome.